Hey, what's up, guys? Welcome back. Welcome back to Herbs class. Herbs class from the crib. 5-minute math today. Today we're here to talk about compound interest, or what I like to call money math. Exactly right. So now IB has a particular formula that they like to use for compound interest. So we're going to get into that formula today. But first, just a real quick talk about interest. So interest is money paid to borrow money. Now, that interest can go in either direction. You can pay a bank interest to borrow money, or a bank can pay you interest to keep your money there so that they can use it. So, in essence, interest is exactly that, the money paid to borrow money. Now, let's get to the formula. Bang! There is our IB compound interest formula. Now, interest can be applied or compounded to whatever money is present there, and at any number of different time intervals. You can compound interest, you can apply interest once a year, you can apply interest once a month, you can even apply interest once a day. But to that end, let's talk about what some of these variables mean. You know, with any formula, the key is knowing what the variables mean. So let's get to talking about that. First, FV. FV stands for future value. And future value is basically the money that you end up with. So you're going to start your investment with a certain amount of money, and you're going to end your investment with another amount of money. The money that you end up with is called the future value. So think of it as end money, right? Good. Future value is the money that you end up with, or end money. Now, PV. PV is called the present value. This is the money that you start out with. In a lot of different equations, you'll hear it referred to as the principal. Or I like to think about it as start money. If FV, your future value, is the money that you end up with, PV, the present value, that's the money that you start with. So present value is exactly that, start money. Good job. All right, moving right along. So what about this R value? Now, this R value is your yearly interest rate as a percentage. Now, you'll notice our formula how this R is divided by 100. Now, if you are going to divide by 100 on your own, you don't need this 100 in the denominator in the formula. However, this formula is set up so that your yearly interest rate, or your APR, some people like to refer to it, annual percentage rate, as a percentage. Now, when you're finally calculating your interest in the formula, you're going to have to divide that by 100 because we need that interest rate as a decimal. Now, it's divided by 100 to remind you to put it in. If you put it in as a percentage, you have to divide by 100 to change it to a decimal. All right. Okay. So moving along. K. Bang. Now notice K shows up twice. So K is the number of compoundings per year. So what that means is, if we're talking compounding interest annually, K would be 1. If we were talking about monthly, K would be 12. However, K is the number of compoundings per year. All right, fantastic. And then moving right along to the final variable, T. T, of course, is the time in years that you spend investing in that particular investment. All right. So now that we know what all of the variables mean, you know what? Hold on one second. Sweet. Okay. Now that we know what all of the variables mean, you will be asked to find any one of these given variables. Now, you will be given all of the other variables, and you will be expected to find the missing variable, of course. Now, that missing variable can be anything from the future value, what you end up with your investment, or that variable you could be asked to find is how much money you start with, the present value. Now, we got a little time, so we can go through a couple of really quick basic examples, because this PEMDAS situation here needs to be considered. All right, fantastic. So tell you what, practice video after this, and we'll practice a couple of these problems. Oh, before we go, now your interest, the actual amount of interest that you pay, will be the difference between your future value and your present value. Good. Remember that. All right, let's do a couple practice problems.